All right, the topic today, BGP neighborship auto discovery and auto neighbor establishment. It's pretty cool. I've always understood between external BGP speakers, you had to statically configure your destination of where you wanted to establish that BGP TCP session to establish that neighborship. Well, I just read about a way to do that automatically. Let's get into this. On Juniper's website, they talk about BGP Auto-Discovered Neighbors. And when you go down, it starts talking about spine and leaf and these different BGP neighbor sessions that you might want to automatically discover. So right away, it seems like this is more positioned for the data center and in an environment that you control. All right. So this is probably not something I would be doing on a public facing upstream BGP neighbor that I'm connecting to on the internet. I'm still going to be very specific in statically defining that. But when you're doing a lot of BGP in a data center, this is a tool that apparently has been created to automate this process. When you scroll down, you see spine 1, spine 2, leaf 1, leaf 2, and virtual machine 1 and 2. Each one of these has a different, unique autonomous system number: 64498, 64499, 64496, 97, 64500, and 64501. So this might come as a surprise to some of you, but in the data center, there are architectures that are recommended for doing external BGP between every node in the data center. It seems crazy a little bit, but there are a lot of recommended architectures for doing so. And so because there's so much BGP going on, to automate the establishment of those neighbors and automate the discovery of those neighbors seems like it is quite advantageous. Something I want to point out here, you must enable IPv6 neighbor discovery for this feature to work, this BGP auto discovery feature. IPv6 neighbor discovery is NDP, Neighbor Discovery Protocol, which is enabled when you enable the INET6 family on an interface. You don't have to configure a unique, globally routable unicast IPv6 address on your interface. You just need to turn on the family and let the Link-Local do the rest. All right, so I'm going to show you about this. Also, I'll link another video I did about Link-Local, just understanding what an IPv6 Link-Local address is. And so let's get going. One more thing. You have to at least have Juno's operating system 21.1R1. To get my first look at this, I jumped into Juniper VLabs. All right, it's a pretty cool place to test out Juniper features and platforms. I'm not going to spend too much time in this video talking about Juniper VLabs. I have other videos for that. I'll link those as well. But there's a lot of different standalone platforms that you can look at, as well as pre-built architectures that you can launch. Okay, the one I launched was a simple OSPF single area. I knew I'd have a couple platforms there that I could try this feature on. And I was very pleased to see that it is running at least the version of software that we need. You might recall a moment ago I mentioned 21.1R1 is when the BGP auto discovery feature began, and this has a little bit better than that, 21.1R3. After waiting probably about 15 minutes, Juniper VLabs will create that topology and notify you that it is done, or you'll see this little active indicator up there. Prior to that, it says it's setting itself up. So again, I'm not going to spend too much time on the VLab platform. Let's dive right into this. I'm opening up a SSH session on VMX1 and an SSH session on VMX2. Okay, there's VMX1 and 2. And just to show that there are no BGP neighbors, show BGP summary on both. Shows BGP is not even running. Now, if you're like me, you're going to want to know, what exactly do I need to make this feature work? When you go to Juniper's website, they have a lot of configuration commands for each one of these VMXs in their example topology. You don't necessarily need all those commands, okay? There are some that are used for other things, like creating interface ranges, okay? But let me show you exactly what I used to get this going. Now, here's what we're trying to do. Create two BGP autonomous systems, 64512 and 64513, and we want these to automatically discover each other. So this is pretty much the configuration. VMX number 1 and VMX number 2. We have to define our local autonomous system number. This is just typical of BGP configuration. So this local VMX is in BGP AS 64512. This other VMX is in BGP AS 64513. Okay? Now, to begin with, these are the three lines that are required for the BGP AutoDiscovery config, and then this is how you enable IPv6 neighbor discovery on the interface. And that's pretty much it. Just to talk it through real quick, BGP typically has a group that you can configure and add configurations inside of that group. So I'm just calling it my-AD. Stands for My Auto Discovery. There's my peer AS. You've got to point to the neighboring AS. Okay. Then here's the two dynamic neighbor configuration lines. You create a template. I called it My AD template. And inside of there, you turn on peer auto discovery. Family INET6 uses the IPv6 neighbor discovery as the means by which you're going to discover your neighbor. Okay? And then you tell it what interface to run it on. And that's pretty much it. Between the two VMXs, you just flip the AS numbers. Your local AS on VMX2 is 64513, and you're pointing to 64512. So to begin with, show BGP summary. We see that BGP is not running on either one of these VMXs. And if you look at the interface, G000, we see that only INET is running, not INET6. So only IPv4 is running. We see protocol INET, but we do not see protocol INET6. And because of that, we will not have any discovered neighbors yet. So let's copy and paste these commands. Here's VMX1. I'm already in config mode. Let's just paste those into there. Show pipe compare. Commit check. Checks the sanity, and it's going to be good. So let's commit and quit. Then let's do the same to VMX2. Go in config mode. Paste that. Show pipe compare. Look for any errors. Juniper Junos is pretty good about telling you if you're missing anything. And then a commit check will check the sanity of it. Now commit and quit. And let's see if we now have IPv6 neighbor or a BGP neighbor. We have neither one. So let's first look at the IPv6 neighbors. We don't see one. Let's look at our interface. Let's look at what our local IPv6 Link-Local address is. Here it is right here. Let's carry that and go over to this router, VMX1, and let's ping VMX2's Link-Local address. We can see that it's pingable. Once it becomes pingable, it is now in the IPv6 neighbor table, and then we can check for BGP neighborship. And there we go. There it is. So we have a peer now to the Link-Local of the far side router, VMX2. All right, we could even look at details of that by copying and pasting that neighbor address right here. And we see we now have a peer to FE80 blah, 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 G00. It even shows you the interface that it's going out. It tells you what the remote AS number is and the local AS number. There we go. And of course, it is an external BGP neighbor session, and it is established. That's pretty much all I got for this one. Thanks.